Hello, everybody. This is the weekly My View text, and it is an excerpt from Planet Earth by Christine Taylor Butler. It's an informational text. A couple things that we should know about informational text right now in our lives is that they're usually all nonfiction, and they're informing us about something. A few of the things that we're going to really pay attention to are the text features, and we're going to talk about how those text features help me infer the meaning of the text. My big takeaway, or the big takeaway this week, is not just, okay, yeah, that's a picture, that's a caption, but what is the caption telling us? How does it relate to the information in the text? And that's what we're going to be doing when we build the anchor chart and during the whole group lesson. So the first part, you guys notice my subheading here is called Above and Below. Below us, our planet is composed of 4 main layers. The outer surface is called the crust. I'm actually going to hide the image there so I can... The outer surface is called the crust. Beneath that are the mantle, outer core, and inner core. Circling overhead is a layer of gases that forms our atmosphere. Each layer plays an important part in Earth's ability to sustain life. For example, plants and animals depend on liquid water on Earth's surface to drink. As a gas, water can travel on winds to fall on places around the world as rain, snow, or hail. I'm looking right here at this diagram, guys. I know it's a diagram because it's got a cross section, a cut out bit of the earth, and it's got arrows pointing, telling me what each part is. It's helping me visualize, okay, that's the mantle, that's the outer core, that's the inner core. The crust. Earth's outermost layer includes the continental crust and oceanic crust. The crust and the uppermost layer of the mantle are broken into sections called tectonic plates. The plates rest on top of a more fluid layer of mantle and are constantly moving. Scientists believe Earth's continents were once joined as a single landmass called Pangaea. Over millions of years, the tectonic plates shifted. This caused Pangaea to break into sections. The sections drifted apart and formed the continents we know today. When tectonic plates slide over or past each other, an earthquake can occur. Sometimes the pressure causes shifts in the oceans. If the ocean earthquake is strong enough, waves can develop into a deadly tsunami. The collision or constant pressure of tectonic plates can create mountain ranges. For example, the Himalayan mountains in Asia grow taller each year. And I see this, as I'm reading this, I make the connections between planet Earth and other things that I have seen or read. And if you guys remember yesterday, we looked at that infographic and we talked about tectonic plates. There's another diagram here. And then we have this, start on page 440, says water on Earth, water on Earth circulates constantly through the water or hydrologic cycle. Liquid water on the planet's surface is heated up by the sun and turns into a gas. This gas, called water vapor, rises into the atmosphere. It gathers into clouds and falls back to the ground as precipitation, such as rain or snow. It collects in bodies of water or soaks into the soil. Then it starts the process over again. The mantle. Earth's mantle is a semi-solid and movable layer of rock. It is composed of silicon, oxygen, iron, magnesium, and aluminum. Sometimes this substance rises through the crust above. It surfaces as a volcanic eruption of molten rock. Scientists believe the mantle is about 1,860 miles deep. This calculation is an estimate. No one has ever drilled deeper than 1.4 miles, 2.3 kilometers beneath the ocean, or 8 miles, 13 kilometers on land. And look at this, is another diagram here with a caption. Islands such as Hawaiian Islands were created as molten rock rose up from the mantle through the crust beneath the ocean. The core. Earth's core has 2 layers. The liquid outer core is composed mostly of iron and nickel and is about 1,400 miles, 2,250 kilometers thick. It is constantly flowing. Its movement around the inner core creates Earth's magnetic field. Enormous pressure and radiation keep this layer hot. The inner core is solid iron. It may spin faster than Earth's other layers. The whole core is estimated to be 11,000 degrees Fahrenheit, or 6,000 degrees Celsius. I find it surprising that Earth's inner core is solid iron. iron, and that it is very hot. The diagram helps me visualize how Earth's core may be as hot as the sun's surface. A layer of protection. Earth's atmosphere wraps the planet like a blanket of insulation. Its two lowest layers are the troposphere and the stratosphere. More layers of thinner and thinner air are above the stratosphere. The troposphere is about 7 miles, 11 kilometers high. It contains the air we breathe. It is 78% nitrogen, 21% oxygen, and 1% other gases. Nearly all of the weather we experience on Earth occurs in the troposphere. The stratosphere is about 30 miles, 48 kilometers high. It contains less water and more ozone than the troposphere. Ozone blocks harmful rays from the sun. The stratosphere and the layers above it also help protect us from objects in space, such as meteoroids. These objects sometimes threaten to crash into Earth. However, a meteoroid creates friction as it moves rapidly through the atmosphere. This usually causes the object to burn up. Hey, we learned about that in Mystery Doug this week. Which way is north? A compass needle points to Earth's magnetic North Pole. But did you know that the magnetic North Pole is not located at the geographic North Pole? The magnetic pole drifts about 6 to 25 miles, 10 to 40 kilometers each year. The north and south magnetic poles sometimes switch places. When this happens, Earth's magnetic field temporarily becomes twisted and scrambled, but this has only happened 170 times in the last 80 million years. After the next switch, a compass needle that would have pointed north will point south. I noticed that Earth is magnetic, and that makes sense since its core is made of iron, right? Which is a metal. That is how a compass works. It points to Earth's magnetic North Pole. I also noticed from the picture and caption that meteors seldom land on Earth, and we also learned that in Mystery Dog Science, right? The big truth, dividing time. Earth is divided into 24 standard time zones. Each time zone is 1 hour ahead of the zone to the west of it. For example, say it is 12 p.m. in Anchorage, Alaska. At that same moment, it is 1 p.m. in Los Angeles, California. Most areas have adopted these standard time zones, but there are some exceptions. China crosses 3 standard time zones, but the country decided to have only 1 time zone. Some regions divide time zones by half hours. Iran, Newfoundland, and Canada, and parts of Australia are examples. Now, I think about what our time zone is, and I can look back at the map and help understand what I've read. There's map locations there. Mission Earth. Technology has come a long way since the days of ancient astronomy. Satellites create detailed images of Earth from space. Probes deep inside the Earth and the ocean monitor the health of the planet. Global Positioning System, GPS, satellites allow us to navigate the planet without having to study the stars. Now scientists can spot problems and react quickly to natural disasters. This helps reduce the devastation the events could cause. The undiscovered deep. Oceans are one of Earth's most abundant resources, but only 5% of the ocean floor has been explored. That is changing. The National Oceanic and Atmospheric Administration is studying deepwater canyons off the coast of Virginia. There they use remote-operated vehicles, ROVs, and sonar. Woods Hole Oceanographic Institution uses a human-occupied vehicle and other underwater machines to explore and map even deeper waters. These missions help explain Earth's geologic processes. I see this photo of the ship. I have a question about it. How does that relate to Earth's features and processes? The caption tells me that this ship is used to drill under the ocean, so it might reveal information about the Earth's structure. The headings also hint at what is deep below the surface. To the center of the Earth. The exact nature of Earth's mantle is still unknown. To solve this mystery, scientists are hoping to drill directly into the mantle and take samples. Geologists plan to drill through a section of the Pacific Ocean floor estimated to be less than 4 miles, 6.4 kilometers thick. Special drills are being designed to handle the stress of boring through the hard oceanic crust. This $1 billion project is planned to start drilling in 2020. I wonder if that happened. I'll have to Google that and look it up. Maybe the pandemic caused it to stop. Exploring Earth's mantle through volcanoes. Antarctica's Mount Erebus is one of Earth's most unusual volcanoes. It is largely covered in ice, but it contains a lake of molten hot lava deep inside its crater. Scientists at the McMurdo Station research facility analyze the gas and lava produced by Mount Erebus. The data helps explain how and why volcanoes erupt. It can also tell us a lot about the mantle's chemical composition. Now, this picture of Mount Erebus shows a volcanic crater. The vapor in the background could be hot gas from the volcano. The text states that Mount Erebus has molten hot lava deep inside its crater. Destination space. Human-made satellites also help us study Earth. The Aqua satellite was launched in 2002. Aqua uses microwave technology to see through clouds and monitor Earth's water cycle. For example, water and ice from melting polar caps could shift ocean currents. Weather would change and Earth's temperature could plunge. Other satellites look for activity signaling earthquakes, tsunamis, or other natural disasters. Satellites can track storms or changes in Earth's climate. To learn how things work in a weightless environment, world scientists designed the International Space Station. ISS welcomed its first astronauts in November 2, 2000. Since then, more than 200 scientists and engineers have visited the station. They have conducted more than 400 experiments. As of 2013, ISS completed more than 57,000 orbits around Earth. Exploration continues to expand. People once thought Earth was the center of the universe. What will we discover next? Where on Earth are you? Do you use GPS to navigate? I know I do. If so, you are receiving information from the 29 GPS satellites orbiting Earth. The U.S. Air Force maintains these satellites. 24 satellites are active. The other 5 are backups. The satellites transmit radio signals to a GPS receiver in your phone or car. Signals from 4 or more satellites are needed to accurately determine your position. Digital maps are built into the receiver. They use the satellite's information to help you navigate. That's fascinating. Okay, guys, respond to the activity so I know that you are doing the reading and you can come to class prepared.